Hello guys, welcome back to Abstronic tutorial. Now, let's discuss how to calculate the transistor using BD139, and the main component of the circuit is transistor. The work of the BD139 transistor is to drive the relay switch, the positive 5V of the battery connected to the coil of the relay switch, and the opposite coil connected to the collector of the BD139. The same power supply, which is connected to the base bias resistor R1 to supply the base of the transistor. The common terminal of the relay switch also connected to the same positive 5V power supply. The normal open terminal of the relay switch connected to 100 ohms resistor, and the opposite connected to the anode of the LED, and the opposite or the cathode of the LED will be connected to the ground. The core power of the relay switch, which is 0.36 watts according to the data sheet. So now we can calculate the current consuming by the relay switch by using the power formula, which is power equivalent to voltage times the current. Then substitute the value of the power, which is 0.36 watts, equivalent to voltage or rated voltage of the relay switch times the current consuming by the relay switch. So the current will be 0.36 watts divided by 5V. Then the current will be 72 milliamp. Now we know the current consuming by the relay switch circuit will be 72 milliamp. So therefore, the collector current must be greater than 72 milliamp. So let's use 100 milliamp current flowing through the collector of the BD139. Now we can calculate the base current of the BD139 by using the current gain formula, and the current gain of the BD139, which is 100 to 250. So let's use the maximum current gain, 250. Now we can calculate the base current of the transistor. So let's substitute the current gain through the formula. IC, the collector current, which is 100 milliamp, equivalent to current gain, which is 250 times IB. So the base current IB equivalent to 100 milliamp divided by 250. So IB will be 0.4 milliamp. Now we can calculate the base bias resistor by using Ohm's law formula. Voltage equivalent to current times the resistance. The voltage dropping from the R1 will be 5 volt minus 0.7 volt for silicon, which is the internal forward voltage equivalent to current 0.4 milliamp times the resistance. Then 5 volt minus 0.7 will be 4.3 volt, equivalent to 0.4 milliamp times R1. R1 will be 4.3 volt divided by 0.4 milliamp. Then R1 will be 10.7 kilo ohms. So let's say R1 will be 10 kilo ohms, converting into commercial value. Sorry guys, I forget to place a diode in between the pin of the relay switch. So now, let me place the diode in the two terminal of the relay switch. And now, let's see how the circuit is working. So when the current injected to the base of the resistor, then the collector emitter will be activated, acting like a closed switch. Now, the current from the power supply flowing through the coil terminal of the relay switch and going out to the opposite terminal, entering to the collector and going out from the emitter and going back to the ground. So therefore, the relay coil will be energized and the common terminal of the relay switch will be shifting to the normal open terminal of the relay switch. Then the current from the battery flowing to the common terminal and going to 100 ohms resistor, entering to the anode and going back to the ground. If we remove the relay switch circuit and test the current flowing through the collector to the ground, will be 100 milliamp. But if the relay switch present in the circuit, then the current equivalent to the current consuming by the relay switch circuit. Now, let's test the base current and the collector current in the actual circuit, and also let's test the current consuming by the relay switch circuit directly in the battery without driver transistor. As you can see, my driver relay switch circuit, the component, the relay switch, the 10K ohm resistor, BD 139 transistor, and the rectifier diode to protect the transistor. Now, let's test the relay switch circuit by using analog tester. You can see the current is 75 milliamp, which is connected directly to the battery or to the power supply. Now, let's compare the current flowing through the relay switch circuit. From the calculation, the current is 72 milliamp, and from the tester, the current almost 75 milliamp. So, the current from the calculation and from the tester almost the same. Now, let's check the base current of the BD 139. So you can see the pointing needle is 40. So this result will be multiplied by 0.01 because the DCM setting will be 2.5. So it is multiplied by 0.01. So 40 times 0.01 will be 0.4 milliamp. Now you can see the result from the tester and the calculation will be the same. And you can see the needle pointing to 75, and this result will be multiplied by 0.001 simply because the DC amp will be setting to 0.25. So 75 times 0.001 will be 0.075 ampere. Then multiply by 1000. So therefore, the current is 75 milliamp, converting into milliamp. So the current flowing from the battery through the relay switch circuit, going to the collector and going out from the emitter back to the ground will be 75 milliamp. Even though the collector current alone 100 milliamp, but still the current flowing based on the relay switch current consuming. Hopefully, everyone understand and learning in my video tutorial. So guys, this is the end of my video. So don't forget to subscribe to my channel, like and share.